Workplace accident analysis. The incident involved the retrieval of a drill motor. The date and time of the incident were not provided. The location was a partition wall. A worker was drilling a hole in a partition wall using a powerful drill motor known as the Widowmaker. The drill bit caught on plywood, causing the drill motor to torque. The worker was thrown off a ladder approximately 4 feet high and landed on concrete. Injuries sustained included a broken hand, 10 stitches in a finger, 11 stitches in an elbow, and general soreness. The causes of the accident were using an oversized hole saw, causing the drill bit to catch on plywood, and operating the drill motor from a ladder without proper safety measures. Contributing factors included overconfidence due to extensive experience in the trade, specifically 34 years, and a lack of sympathy from coworkers due to unsafe work practices. Recommendations to prevent similar incidents. Firstly, always use the correct size drill bit for the intended hole. Secondly, ensure proper safety measures are in place when operating power tools from elevated surfaces. Thirdly, regularly review safety protocols and reinforce the importance of working safely. And fourthly, provide proper training and supervision for all workers, regardless of experience. Lessons learned. Firstly, even experienced workers can make mistakes. Secondly, it is crucial to follow safety procedures at all times. Thirdly, overconfidence can lead to complacency and increased risk of accidents. And fourthly, a safe work environment benefits both the individual worker and the entire team. When using power tools, several safety aspects should be considered. Firstly, before operating any power tool, always read and understand the manufacturer's instructions and safety guidelines. This includes understanding the tool's limitations, proper usage, and potential hazards. Secondly, inspect the power tool before each use to ensure it is in good working condition. Look for any damage, loose parts, or frayed cords. If any defects are found, do not use the tool until it has been properly repaired or replaced. Thirdly, always wear appropriate personal protective equipment, PPE, when operating power tools. This may include safety glasses or goggles to protect your eyes from flying debris, hearing protection to reduce noise exposure, gloves to protect your hands, and a dust mask or respirator to prevent inhalation of dust or fumes. Fourthly, ensure the work area is well lit and free from clutter. Clear the area of any obstacles that could cause you to trip or lose your balance. Good lighting will help you see what you are doing and reduce the risk of accidents. Fifthly, use the right tool for the job. Do not try to force a tool to do something it was not designed for. Using the wrong tool can not only damage the tool but also increase the risk of injury. Sixthly, maintain a firm grip on the power tool and keep both hands on the tool whenever possible. This will help you maintain control of the tool and prevent it from slipping or kicking back. Seventhly, be aware of your surroundings and avoid distractions while operating power tools. Pay attention to what you are doing and do not allow yourself to be distracted by conversations, phone calls, or other interruptions. Eighthly, never operate power tools when you are tired, under the influence of drugs or alcohol, or taking medication that could impair your judgment or coordination. Ninthly, when using power tools on ladders or scaffolding, ensure the ladder or scaffolding is stable and secure. Follow proper ladder safety guidelines, such as maintaining 3 points of contact and avoiding overreaching. Tenthly, keep power cords away from heat, oil, sharp edges, and moving parts. Damage caused can create a fire hazard or electrical shock hazard. 11thly, always unplug power tools when they are not in use before making any adjustments or repairs, and when changing accessories such as drill bits or saw blades. 12thly, store power tools in a safe and dry place when they are not in use. Keep them out of the reach of children and unauthorized users. 13thly, regularly inspect and maintain your power tools to ensure they are in good working condition. This may include lubricating moving parts, sharpening blades, and replacing worn or damaged components. 14thly, consider the use of cordless power tools, which can eliminate the risk of tripping over cords and provide greater freedom of movement. 15thly, attend safety training courses to learn about the safe operation of power tools and to stay up to date on the latest safety practices. 16thly, implement a lockout tagout, LOTO, procedure when performing maintenance or repairs on power tools to prevent accidental startup. 17th, use ground fault circuit interrupters, GFCIs, when operating power tools in wet or damp locations to protect against electrical shock. 18th, never remove or bypass safety guards or other safety devices on power tools. These devices are designed to protect you from injury and should always be used. 19th, be aware of the potential for noise-induced hearing loss when operating power tools. Wear hearing protection to reduce your exposure to loud noises. 20th, follow any additional safety guidelines or recommendations provided by your employer or safety professionals. When drilling into walls, several additional precautions should be taken. Firstly, before drilling into any wall, be sure to check for hidden electrical wires, plumbing pipes, or other obstructions. Use a stud finder or other detection device to locate these hidden hazards. Secondly, if you are unsure of what is behind the wall, turn off the power to the circuit breaker that supplies electricity to the area you are drilling in. This will help prevent electrical shock if you accidentally drill into a live wire. Thirdly, wear safety glasses or goggles to protect your eyes from dust and debris that may be released when drilling into the wall. Fourthly, use a drill bit that is appropriate for the material you are drilling into. Using the wrong drill bit can damage the wall or the drill bit and increase the risk of injury. Fifthly, start drilling slowly and gradually increase the speed as you gain control of the drill. Avoid applying too much pressure, which can cause the drill bit to bind or break. Sixthly, if you encounter resistance while drilling, stop and check for obstructions. Do not force the drill bit, as this can cause it to break or kick back. Seventhly, use a dust collection system or vacuum cleaner to remove dust and debris as you drill. This will help keep the work area clean and reduce the risk of inhaling harmful dust particles. Eighthly, when drilling into drywall, use a drywall anchor to provide additional support for screws or other fasteners. Ninthly, when drilling into plaster, use a special plaster drill bit to prevent chipping or cracking the plaster. Tenthly, when drilling into tile, use a diamond tip drill bit and apply water to keep the drill bit cool and prevent the tile from cracking. 11thly, be aware of the potential for asbestos exposure when drilling into older walls. If you suspect that asbestos may be present, have the wall tested by a qualified professional before drilling. 12thly, when drilling into concrete or masonry, use a hammer drill and wear appropriate respiratory protection. 13thly, after drilling, clean up any dust or debris and dispose of it properly. 14thly, inspect the drilled hole to ensure it is the correct size and depth for the intended purpose. 15thly, if you need to drill multiple holes, use a template or guide to ensure they are evenly spaced and aligned. 16thly, be aware of the potential for noise and vibration when drilling into walls. Wear hearing protection and use vibration dampening gloves if necessary. 17thly, when drilling into walls that are painted or wallpapered, use masking tape to prevent chipping or peeling the paint or wallpaper around the hole. 18thly, if you are drilling into a wall that is load-bearing, consult with the structural engineer to ensure that the drilling will not compromise the structural integrity of the wall. 19thly, before drilling into a wall, check for any permits or approvals that may be required by local building codes. 20thly, always err on the side of caution and take the time to properly assess the situation before drilling into any wall. When working on ladders, several safety precautions should be observed. Firstly, always inspect the ladder before each use to ensure it is in good working condition. Look for any damage, loose rungs, or worn parts. Do not use a ladder that is damaged or defective. Secondly, choose the right ladder for the job. Select a ladder that is the appropriate height and weight capacity for the task you are performing. Thirdly, set up the ladder on a firm, level surface. Ensure the ladder is stable and will not tip over. Fourthly, maintain 3 points of contact with the ladder at all times. This means keeping 2 hands and 1 foot or 2 feet and 1 hand on the ladder while climbing or working. Fifthly, do not overreach while working on a ladder. If you cannot reach something comfortably, move the ladder closer to the work area. Sixthly, never stand on the top rung of a ladder. The top rung is not designed to support weight and can be dangerous. Seventhly, avoid carrying heavy or bulky objects while climbing a ladder. Use a rope or hoist to lift materials to the work area. Eighthly, be aware of your surroundings and avoid distractions while working on a ladder. Pay attention to what you are doing and do not allow yourself to be distracted by conversations, phone calls, or other interruptions. Ninthly, never use a ladder in windy or stormy conditions. The wind can cause the ladder to become unstable and increase the risk of falling. Tenthly, keep the area around the ladder clear of obstacles that could cause you to trip or lose your balance. 11thly, when using a ladder near doorways or walkways, block off the area to prevent people from walking into the ladder. 12thly, use a ladder with slip-resistant feet to prevent it from slipping on smooth surfaces. 13thly, never leave a ladder unattended while it is set up. 14thly, store ladders in a safe and dry place when they are not in use. Keep them out of the reach of children and unauthorized users. 15thly, attend safety training courses to learn about the safe use of ladders and to stay up to date on the latest safety practices. 16thly, when working on ladders near power lines, maintain a safe distance to avoid electrical shock. 17thly, use a fiberglass ladder when working near electrical hazards. Fiberglass ladders are non-conductive and will not conduct electricity. 18thly, never allow anyone to stand or walk under a ladder while it is in use. 19thly, use a ladder stabilizer or leveler to provide additional stability on uneven surfaces. 20thly, always err on the side of caution and take the time to properly assess the situation before using a ladder. The use of ground fault circuit interrupters, GFCIs, is crucial for electrical safety, especially when using power tools. A GFCI is a device that monitors the electrical current flowing through a circuit and quickly shuts off the power if it detects a leakage current that could pose a shock hazard. Versely, GFCIs are designed to protect people from electrical shock by detecting ground faults, which occur when electricity flows through an unintended path, such as through a person's body. Secondly, GFCIs work by comparing the amount of current flowing into a circuit with the amount of current flowing out of the circuit. If there is a difference of more than a few milliamperes, the GFCI will trip and shut off the power. Thirdly, GFCIs are required by electrical codes in many locations, particularly in areas where there is a high risk of exposure to water, such as bathrooms, kitchens, and outdoor areas. Fourthly, GFCIs can be installed as receptacles, circuit breakers, or portable units. Receptacle GFCIs are installed in place of standard electrical outlets, while circuit breaker GFCIs are installed in the electrical panel. Fifthly, portable GFCIs can be plugged into standard electrical outlets and provide GFCI protection for any equipment plugged into them. Sixthly, GFCIs should be tested regularly to ensure they are working properly. The test button on the GFCI should be pressed to simulate a ground fault and verify that the GFCI trips and shuts off the power. Seventhly, GFCIs can prevent serious injuries or even death from electrical shock. They are an essential safety device for any home or workplace. Eighthly, when using power tools in wet or damp locations, always use a GFCI protected extension cord or outlet. Ninthly, GFCIs can also help prevent electrical fires by detecting and interrupting ground faults that could cause overheating and ignition. Tenthly, GFCIs are relatively inexpensive and easy to install, making them a cost-effective way to improve electrical safety. 11thly, GFCIs should be installed by a qualified electrician to ensure they are properly wired and functioning correctly. 12thly, GFCIs can be used with a variety of electrical equipment, including power tools, appliances, and lighting fixtures. 13thly, GFCIs are particularly important when working with power tools that have metal housings, as these tools can pose a greater risk of electrical shock if a ground fault occurs. 14thly, GFCIs can also help protect against nuisance tripping, which can occur when there are small, harmless ground faults in a circuit. 15thly, GFCIs are an important part of a comprehensive electrical safety program. They should be used in conjunction with other safety measures, such as proper grounding, insulation, and lockout-tagout procedures. 16thly, GFCIs should be replaced if they are damaged or malfunctioning. 17thly, GFCIs can be used in both residential and commercial settings. 18thly, GFCIs are available in different current ratings to accommodate different electrical loads. 19thly, GFCIs should be installed in accordance with local electrical codes and regulations. 20thly, always consult with a qualified electrician if you have any questions about GFCIs or electrical safety. Lockout-tagout (LOTO) procedures are essential for preventing accidental startup of equipment during maintenance or repair. Firstly, lockout-tagout is a safety procedure used to ensure that dangerous machines are properly shut off and not able to be started up again prior to the completion of maintenance or repair work. Secondly, the procedure requires that hazardous energy sources be isolated and rendered safe before any work is started. Thirdly, lockout-tagout procedures are required by law in many countries and are an important part of a comprehensive safety program. Fourthly, the first step in a lockout-tagout procedure is to identify all of the energy sources that could pose a hazard to workers. This may include electrical, mechanical, hydraulic, pneumatic, thermal, and other types of energy. Fifthly, once the energy sources have been identified, they must be isolated and rendered safe. This may involve disconnecting electrical power, closing valves, blocking moving parts, and releasing stored energy. Sixthly, after the energy sources have been isolated, they must be locked out using locks and tags. The locks prevent the energy sources from being turned on, and the tags provide information about why the equipment is locked out and who is authorized to remove the locks. Seventhly, only authorized employees are allowed to perform lockout-tagout procedures. These employees must be properly trained and knowledgeable about the hazards involved. Eighthly, before starting any work, the authorized employee must verify that the equipment is properly locked out and tagged out. This may involve testing the equipment to ensure that it cannot be started up. Ninthly, during the maintenance or repair work, the authorized employee must ensure that the lockout-tagout procedures remain in place. Tenthly, after the maintenance or repair work is completed, the authorized employee must remove the locks and tags and restore the equipment to its normal operating condition. 11thly, before removing the locks and tags, the authorized employee must ensure that all workers are clear of the equipment and that it is safe to start up. 12thly, lockout-tagout procedures must be documented and readily available to all employees. 13thly, lockout-tagout procedures must be regularly reviewed and updated to ensure they are effective and comply with all applicable regulations. 14thly, lockout-tagout procedures should be used whenever maintenance or repair work is being performed on equipment that could pose a hazard to workers. 15thly, lockout-tagout procedures are not a substitute for proper training and safe work practices. 16thly, lockout-tagout procedures can help prevent serious injuries or even death. 17thly, lockout-tagout procedures should be used in conjunction with other safety measures such as personal protective equipment, machine guarding, and hazard communication. 18thly, lockout-tagout procedures should be tailored to the specific equipment and hazards involved. 19thly, lockout-tagout procedures should be enforced consistently and fairly. 20thly, always consult with a qualified safety professional if you have any questions about lockout-tagout procedures.